Good morning, ladies and gentlemen. We are the Team Eco Girls from SMK King George V Seremban. My name is Rahini Saishri Surendran. My team member is Nur Farah Alia binti Muhammad Farshi. Our project is entitled Waste to Green Eco Construction. Mrs. Gan Bin Hoon is our teacher who helped supervise our project, and Mr. Surendran Virasamy who guided us through the technical aspects of the project. The problem we are facing is the over-reliance of natural material. Nowadays, bricks available in the market usually consist of natural resources such as sand and clay. The cost of the bricks are escalating as well. We may no longer be able to sustain raw materials such as limestone, which is used to make cement, real sand and clay, which are used to make bricks and other construction material. In addition to the sustainability of the resources, the severity of plastic pollution is also increasing. This not only destroys the marine system and the land ecosystem, but also contributes towards the greenhouse gases and global warming. Our objectives are to save the natural resources, sustain the earth, and to identify a suitable material to replace natural elements such as sand, limestone, and granite. We also aim to reduce the severity of plastic pollution. Did you know that to make cement, we have to scrape down the mountains to obtain limestone, and we have to dredge riverbeds for sand? Our project goal is also to achieve two of the UNDP's Sustainable Development Goals. They are Goal number 9, Industry, Innovation and Infrastructure, and Goal number 13, Climate Action. Our project is also in line with Malaysia's 2030 roadmap towards zero single-use plastics. There is a drastic increase in plastic imports, especially from the USA, Japan, and Germany, contributing to more than 75% of Malaysia's imports. Our goal is to reduce these imports and provide clean and efficient recycling centers. Through research and development, this project will be able to contribute a cost-effective solution with proper framework and policy in place. Next is how a small concern from a child can bloom into a research idea. The idea bloomed from one of our students and her experience when she was younger, traveling from KL to Ipoh to visit her grandparents. She was enjoying the scenery throughout the journey. When they passed an area near Ipoh, she saw the mountains surrounding being cut down. She was sad and asked her father why this was happening. Her father told her that it was for limestone for the cement production. She did not think much of it then, but today, this idea is what brought us here. After doing some research, we found out that building materials such as bricks, roof tiles, and pavement blocks require cement and sand. Bricks usually have a composition ratio of 1 part cement and 4 parts sand. The cheaper ones would have a 1 to 6 ratio of cement and sand. With this in mind, through research and findings, we decided to substitute cement with paddy husk ash and substitute sand with plastic material such as plastic material from recycled HDPE, PVC, PP, and PE piping, and plastic bottles. We decided to produce a prototype of a construction brick. We call it Eco Bricks. Before I go further, I need to explain the materials and tools that was required in the preparation of the project. Item 5.1 shows the material and tools required in the fabrication of the wool. Item 5.2 shows the material and equipment required for the production of paddy husk ash. Item 5.3 shows the recycled material and equipment required to produce crushed plastic. Continuing from the earlier slide, item 5.4 shows the requirement for other raw material. Item 5.5 shows the requirement for other equipment and tools required. Item 5.6 shows the equipment required for the compression testing. I will be showing you the methodology in how we created a prototype of the actual Eco Brick. The following are the processes that were involved in the manufacturing of the brick. Number 1. Mold making process. Number 2. Burning of the paddy husk to ash. Number 3. Crushing and separating the carbon from the ash. Number 4. Crushing and shredding the plastic. Number 5. Preparing the different mixture ratio. Number 6. Standard measurement casting for the different material. Number 7. Curing of the construction material and samples for 7, 14, 21 and 28 days. And number 8. Testing of the construction material. The Malaysian Standards 7.6, 1972 and British Standards BS 3921 were followed as guideline in the production and testing of the bricks. The first process is to make the molds for the bricks. As you can see, it involves cutting of the wooden planks to size, aligning the wood in preparation of the mold, setting and marking the mold to the size specified in the standards, fastening the molds, laying the mold for the next process. The subsequent process is to burn the paddy husk to ash, ideally above 700 degrees Celsius in a controlled environment such as an incinerator plant. However, it was not possible to build one on our own, and the minimum wage to burn it in an incineration facility is 10 tons, so we had to burn it under control. The process included preparation of the paddy husk, burning the paddy husk above 700 degrees Celsius, allowing the paddy husk to turn into ash as it contains high amounts of silica suitable for bonding. Then, we crushed and separated the carbon from the ash through a sieving process. This is because when carbon is mixed into the bricks mixture, it reduces the durability and the strength of the bricks. The fourth process is to crush and shred the plastic material. It took a long time to grade the plastic by ourselves, so a friendly recycler helped us to crush the plastic material. The plastic has to be fine coarse to provide maximum bonding of the surface areas. After that, we prepared the different mixture ratios for each brick. This process involves mixing the different elements of the raw and recycled material. The mixtures are measured based on a standard measurement cup. The ratios of the mixture is poured into the container filled with water. A hand mixture is used to blend the different compositions. There are 3 mixture processes. We name them paddy husk mixture, or in short PH mixture, high density polyethylene mixture or HDPE mixture, and polypropylene mixture, or in short PP mixture. The first mixture, the PH mixture, has a ratio of 0.5 cement, 1.5 paddy husk ash and 2.5 sand. The second mixture, the HDPE mixture, has a ratio of 0.5 cement, 0.5 paddy husk ash, 2.0 sand and 2 HDPE plastic. The final mixture is the PP mixture that has a ratio of 0.5 cement, 0.5 paddy husk ash, 2 sand and 2 PP plastic. The following process is the casting process, where the mixture in a standard measurement mold for the different mixture ratios. When casting, the cast should be compacted to remove any air which may cause cavity. The cast is then leveled to get an even finish. The cast is then left to settle. Once the caster bricks has set after 3 days, we remove the molds and label the bricks according to material type. We place all the bricks in water for a curing process of 7, 14, 21 and 28 days. The longer the cast is left to cure, the stronger the bricks become. Using paddy husk ash in the bricks takes longer to cure, but stronger as time goes compared to using cement. This is EcoBricks, the final product of our innovation. The tests are conducted in accordance to the Malaysian Standards 7.6, 1972 and British Standards BS 3921. There are 3 common requirements the bricks have to comply with: the absorption rate, strength and efflorescence. The first test is the absorption test. The bricks are soaked in water for 24 hours and the mass of the bricks are measured before and after soaking. This is the formula in calculating the absorption rate. Absorption rate cannot exceed 20% as the bricks will not be suitable for construction. The second test is the compression test. We use the top loading method to test the specimen which was cured for 7, 14, 21 and 28 days. This is the formula in calculating the compression test. The third test is the efflorescence test. The bricks is partially soaked in water to the height of 20 millimeters. The water is allowed to fully evaporate and dry. The cycle is repeated again. Once all the water has evaporated, the bricks is checked for traces of efflorescence, scalings and flakings. This is more of a visual check. From the results shown in the table, we can see that after 28 days curing, the PH brick has a compression strength of 9.88 Newton per millimeter square. The PH brick recorded a 13% absorption rate. There were no signs of efflorescence. From the table, we can see that after 28 days curing, the HDPE brick has a compression of 3.1 Newton per millimeter square. The HDPE brick shows that it has a 10% absorption rate. There were no signs of efflorescence. From the table, we can see that after 28 days curing, the PP brick has a compression of 0.81 Newton per millimeter square. The PP brick shows that it has a 23% absorption rate. There were no signs of efflorescence. From the results, our finding is that the PH mixture has the highest compression strength and acceptable absorption rate and falls within the requirements of both the MS and BS standards for load-bearing applications. The PH mixture can be used for buildings, bricks and roof tiles. The HDPE mixture has a low absorption rate and medium compression strength. The HDPE mixture has the potential to be used as low load-bearing walls and pavement blocks. The PP mixture has very low compression strength and very high absorption rate. It can be used as garden patios or landscape material. The mixture can be further developed to produce roof tiles, pavement blocks, floor tiles and wall tiles. With proper funding and research support, we can further develop the use of recycled material, both organic and non-organic, to create new construction material. Other organic material that can be used are jute, cane and coconut fiber to replace the paddy husk. We can also use recycled oil such as engine oil and gear oil to be used as replacement material for the construction of flexible pavement. There is a big market for this product where we can contribute towards recycling of plastic and waste material while sustaining the natural resources. The product has a commercial value as it complies to standards. It is easy to manufacture and does not need complex machinery. The product itself meets the standards and is comparable in strength and is durable. We can also produce it at a very competitive price. Our target market would be housing development, hardscape and landscaping contractors, and export to third world countries. Our research encompassed the study of silica contents in paddy husk ash. It also involved the study of fly ash in cements. Hence, came the idea of using paddy husk ash in concrete material. They are more stronger and durable than conventional Portland cement, but takes longer to cure. These are some of the research references. We would like to thank our collaborator, Manipal International University, and our teacher advisor, Madam Gan Bin Hoon, and our mentor, Mr. Surendran. We also like to thank the organizers of APCYS and MISO for allowing us to take part in this competition. Thank you again.